In this Hardhat crash course, you learn everything you need to know about Hardhat. We'll develop smart contracts, deploy them both on public testnet and local development blockchain, write tests against them, and debug smart contracts, all using Hardhat. And we'll explore the famous console log debugging feature that Hardhat provides us. So if you like content like this one, make sure you destroy that subscribe button and let's get started. What is Hardhat? It's a alternative development framework to Truffle that helps basically developers to manage and automate the recurring boring tasks that are inherent to the process of building smart contracts and decentralized application. And basically it has all the tools you need to develop, deploy, test and debug your smart contracts, and it comes built in with the Hardhat network. This is like a local development blockchain designed for development that will deploy our smart contracts to, and it uses Waffle as a testing framework to test our smart contracts. So let's start coding. So for this project you'll need to have Node.js and npm installed because Truffle is a JavaScript framework. So to install Hardhat, so to install Hardhat you have to have Node and npm installed. So go into Visual Studio Code, open a new folder, pull up the terminal, and in the terminal we'll initialize an empty npm project. To initialize empty npm project, just do npm init and -y to say yes to every one of these questions. After the npm project is initialized, you'll get this package.json. This is basically a file with all of the dependencies, and let's install Hardhat by saying npm install Hardhat. So after Hardhat is installed, you can see that we've got a node modules. This is where our Hardhat is stored, and we have this new package log.json file. And now to create our Hardhat project, we'll do npx, and npx just executes npm packages, and we'll do npx Hardhat. So we get a couple of options here to create a basic sample project, advanced project, but we'll create an empty Hardhat just configuration file so we can create everything from scratch and learn how Hardhat works. So this will just create a configuration Hardhat file, and in here we want to change, this file is used in Hardhat to just configure all the blockchains that you use in your Hardhat project and for the Solidity version, and we'll change this to 0.8.0 because that's what I want to use to develop my smart contracts. As the Hardhat documentation says, plugins are the backbone of Hardhat, so it's very important to understand what they do. These are basically just reusable configuration, and anything that you can do with a plugin, you can do in your configuration file in this Hardhat config file. You can create your own plugins, but there are some official plugins that we're going to use for our project. The two that we're going to use are this Hardhat Ethers plugin and the Hardhat Waffle plugin. And Hardhat Ethers plugin basically helps us. It integrates the Ethers.js library into our Hardhat project, and the Hardhat Waffle plugin will help us test our smart contract, and it will integrate the Waffle library into our project. The Hardhat Waffle plugin basically integrates the Waffle library into our Hardhat project, and this Waffle, it's really important to understand that the Waffle library, it uses under the hood the Chai and Mocha library. These are both JavaScript libraries used for assertions, and this will help us to test our smart contract. So this is the Mocha JavaScript library documentation, and this is the Chai documentation. So let's install all the plugins that we're going to use in our project. First with npm install. So first we'll install the Ethers library. This is used to interact with our smart contract on the blockchain that will deploy to our Hardhat blockchain. This is our Ethers plugin that basically just takes Ethers and puts it in our Hardhat project, and it gives us, as you'll see later, an ethers object. This is the waffle library that we'll use for testing, and this is the waffle plugin, and we'll also have to install separately the child library. So after that is done, let's clear the terminal and learn about Hardhat tasks. So basically everything you do in Hardhat is defined as a task. You can create your own task, and basically every time you are running Hardhat command from the CLI, from the terminal, you're running a task. To see the list of all the tests you can run on all the predefined tasks at least, just do npx hardhat once again. This will give us the available tasks. So if we do for example compile one, and you do task first by saying npx hardhat and then the actual task. So if we do npx hardhat compile, this will compile our smart contracts, but we don't have created any smart contract as of now. So let's go ahead and create one. So let's go ahead and create our smart contract. So here all the contract will be stored in a contracts folder. So let's create it by saying new folder, then contracts. I'll create a contract by right clicking new file, and I'll call this favorite number. Inside this contract I want to first put this comment here so the compiler doesn't present warnings to me, and then I want to specify the solidity version I'm going to use in my smart contract by saying pragma solidity. We'll use the 0.8.0 version or any version above up to 0.9. That's what this sign basically tells us. I'm going to create a contract by using the contract keyword, and we'll call this the same way that we called our file. So favorite number. In here, this contract will basically be very simple, and it will only store my favorite number, and we'll have a function that changes the favorite number. So this is the variable where my smart contract will be stored. I'll have a constructor function. A constructor, if you didn't know, is a function that gets called only once when you deploy the smart contract, and this will take in a number. This will basically set a value to our initial value to our favorite number variable. So we'll say my favorite number is equal to the number that we're passing in my constructor, and we'll have another function that sets my favorite number, and here this one again takes in a number. This will be external function, so which means anyone can call it from the outside, and we will do the same thing that we have done in the constructor. So now that I have created my contract, I can run a task, or basically I can compile the contract by saying npx hardhat compile. After the compilation has finished, we get two new folders. The first one is cache. This one just Hardhat saves some cache about it, and this one is the one you really need. So this is where Hardhat stores the artifacts for your smart contract. An artifact is basically a JSON file that represents the smart contract. JavaScript uses this JSON file to interact with the smart contract on the blockchain. So if I open artifacts and go into contracts, you can see I have favorite number JSON file, and this is the artifact from my favorite number contract. Now that we have created our smart contract, let's go ahead and write tests against it, and all the tests are going to be stored inside of a test folder. So let's go ahead and create the test folder. Inside here I'll create a new file. This will be a JavaScript file, and Mocha, the JavaScript framework, has this way of defining test with a describe block, and inside of this describe block we're going to put multiple tests. Describe basically acts as a block in which you can put a group of tests. So the first argument that describe takes is description, let's say favorite number contract. This description is just what it describes the group of tests we're going to put in the describe block. The second one is a callback function, and I didn't mention, but we get this describe block from the Mocha framework, and that's why I said in the beginning we use the waffle framework, but the waffle framework, or library I should say, uses the Mocha framework in the background and the Chai framework. And before we test our smart contract, we want to deploy it first. And you define tests with the it block, but let's first use the before each block. And with this one runs before each test has been run. So it's a very good place to deploy your smart contract so you can test it. This one takes in a function again, so let's a callback function. And in here I want to access my ethers object that I get from the ethers plugin, but first we have to require that in the Hardhat config file. And whatever basically a plugin we require here, it will give us the ethers object in the entire Hardhat runtime environment, and we can use the ethers objects in our tests. And instead of requiring the ethers plugin, we can require the waffle plugin, and this will indirectly require the ethers plugin. So let's go back to our contracts. To deploy our contract, we're going to say ethers. This is the ethers object, and then say get contract factory, and then provide the name of our smart contract. This will create a factory contract, and because we are now interacting with a blockchain, this is asynchronous operation, we have to use the wait keyword. And since we're using the wait keyword, we have to provide the async here, that this is an asynchronous function. We'll store this inside of a constant. We'll call this favorite number. Now to deploy our smart contract, we'll use this factory contract and just say .deploy. And remember, this smart contract takes in an argument, basically our favorite number. Here we'll say that it's 7, and we'll save this inside of a favorite number contract. And the deploy method on this factory contract starts the deployment of my contract. This favorite number contract will be a global variable that I'll define here, because we're going to use this variable down in my tests. And we can await for the contract to be deployed by just saying await contract.deploy. Let's create our test with the it block. And the it block is basically just a test. So this test should return 7 as my favorite number. So let's just test if we get 7 as our favorite number. This the second argument is again a callback function. We'll assert this by using assertions, using the expect assertion from the child library. So let's import that. So now I didn't mention this, but what you can do is, now that we have our favorite contract as a JavaScript object, we can call all the methods that we have on our smart contract. And since we have defined my favorite number variable is public, we get a my favorite number function that we can call that returns the number variable. So access the contract and say my favorite number, and I'll wrap this inside of a expect block, and we expect this result that we get from my favorite contract function to equal 7, because that's what we defined here. So this is our first test. Let's write the second one, and in the second one we'll change the number and see if it changes. It should return 10 as my favorite number, because that's what I'll pass. We can call the set my favorite number function by just accessing the contract and then saying set favorite contract, and we'll pass 10 now. And I forgot to add this, but since we're interacting with a contract, this is asynchronous operation, so we have to add await here, and this has to be an asynchronous function, and the same applies here. We'll save this result that we get from calling set my favorite number function inside of a variable. Let's call this change number transaction. And then this is basically not finished. It doesn't tell us for sure, it's not guaranteed that the transaction has been mined, and we can make sure that it has been mined by calling the wait function on our transaction. And then we can do the same thing we did here but we can expect but this time we'll expect that the number is equal to 10. And forgot to mention, but this get contract factory function is a function that we get from the ethers plugin. So if you are using just ethers, you're not going to get this. So let's run our test by saying npx hardhat test. So this is another test that we have. The tests have finished running. As you can see, both of them are passing. So let me show you now how you can debug smart contract. Now to debug our smart contract and the famous console log feature that we get, let's try out that. So go into the smart contract and to use the console log feature. And for those of you that didn't know, console log basically allows us to print variables inside of our smart contract. To use the console log feature, you just have to import console log. And by the way, this console log uses the same formatting features as the console log in Node.js, which means we can do something like console.log inside my setFavoriteNumber function and say that we are changing my favorite number from this thing to this thing. And these are just placeholders, and we'll add some variables right now here. The first one is my favorite number, the current value of my favorite number, and the one we are changing to is this number here. And to see this being printed out, you can run npx hardhat test once again, and you can see this being printed out. So we're changing my favorite number from 7 to 10. So we have created, we have tested, and we have seen how you can debug smart contract. So let's go ahead and deploy now the smart contract to our Hardhat development blockchain. And for this you need to create scripts. So let's create a new folder, call this scripts. Inside I'll create a deploy.js script. This is the script that will deploy our smart contract. And here I want to define a asynchronous function. Call this main, and we'll call this main function here. And inside here we'll do the same thing that we have done in our tests. So we'll create a contract factory. This is how you deploy contract using ethers. And then we'll just call the deploy method on this favorite number contract factory. We'll save this into our contract. We'll get this contract object in JavaScript. Then we can call deployed, so we can wait when it's deployed, and then I can print out the address to which my contract was deployed by just accessing the address property on my contract. To deploy this, we have to run our blockchain first by saying npx hardhat node, and if I run this, I should get 20 accounts available from the Hardhat network, as you can see. And now I'll leave my Hardhat running in the background while I open a new terminal and run npx hardhat run, and the network would be localhost, so we want to deploy on our Hardhat local development blockchain, and we'll run this script, that's this deploy.js script, inside our scripts folder, and we'll get an output that my contract was deployed to this address. We have deployed our contract to the local development blockchain, so let's go ahead and now deploy it to a public testnet. We'll use ropsten for this example, and you have to have your MetaMask account connected to the ropsten test network, but more importantly, you have to have some testnet ropsten ether, and we have to configure our Hardhat project to know about the ropsten test network, and we have to provide Hardhat our private key. And you can get your private key if we go here into account details and export private key. And to connect to any blockchain or public testnet, you have to have a node to actually connect to the blockchain. But if you want to, if you don't want to be running your own node, you can use a node provider like I'm doing here with Alchemy. So they will run a node for us that we can connect to only using a key. And to get your key, you have to, of course, make an Alchemy account. It's totally free. you have to choose the ropsten network. You have to create an app, and then you can click on view key. So make sure you copy the key, then go to your Hardhat project. We have to configure our ropsten test network, and we can do this here. So under solidity, add networks, and inside networks you can define as many networks as you like. This is my ropsten blockchain, the URL. This is the URL that we use to connect to our node, and this is where you have to put in your key that you copied from the Alchemy dashboard, and this takes in accounts that we'll use to deploy the contract to, and I'll just have one account here, and this is where this variable will store the private key to your account. So paste in your private key here that you previously copied from your MetaMask, and I use a MetaMask account only for testing purposes, so there are no funds associated with this account, and I recommend you do the same. After you've configured the network and input your private key, you can deploy the contract by saying npx hardhat run, basically the same thing, where the same command we use to deploy our contract to the local development blockchain, but now we're specifying that we want to deploy to the ropsten testnet. So run this and expect this to take a while because we're deploying to a public testnet. So the contract was deployed to this address ending in 270. So now, because this is a public testnet, it has an actual blockchain explorer that we can use to see if the transaction happened. So if I go into the ropsten testnet network blockchain explorer and search for my address, you can see I have this transaction has been done 1 minute ago. And if I go here into the transaction, you can see from my address I have created this contract which ends in 270 as we got this output here from the terminal.